Hello guys, in this video we are going to talk about searching, and searching is one of the operation which can be performed on any data structure. In this class we are going to discuss about searching which is performed on arrays, and also we have two types. One is linear or sequential search. The one more important technique is known as binary search. Before we will define for what is searching, let us know what is searching in real world also. For example, we are going to check is our name is present in voter list or not. If it is present, then only we can vote, otherwise we cannot vote. Like that, searching also can be performed on any data structures like arrays, stacks, queues, linked list, anything. In this session, we are going to discuss how searching is performed on array. Okay, and we are going to discuss mainly about sequential search. Then, what is sequential search or what is linear search? Linear or sequential search is the process of searching an element in the list, or let us say in the array, by checking key element with the elements which are present in the list one after the other. That is known as searching or linear search. And search may be successful and either it may be unsuccessful. If the element is present in the list, that is known as successful search. If the element is not present in the list, that is known as unsuccessful search. Let me explain today the algorithm for linear or sequential search is like this. Directly I would like to write steps here. The first step is to read list. Say list maybe means read the values of array. Okay. Second step, read key element. Here key elements refers to the search element. The third step is to set position as -1. It means initialize position as non-existing position. What it means? Means we initialize the position, it is a variable, at as -1, means that array indexes are starts from 0 up to the n, right? It never starts from -1, means -1 indexing is not there in the list, so that this is a non-existing position. And fourth step is compare the element with the key element from the starting of the element or from the first element in a list. That is, for indexing starts from 0 up to the total size, I take n here. N is size of the array. Okay. Next, I is incremented by 1. Here within this loop we are taking loop because we have to repeat it. We have to check it for the first element, that is from 0th element, and increment it by 1, and check the key element with the second element, third element, fourth element, like this. Within this loop we have to compare, so that take the condition if key is equals to let me take list of I, or you can take array of I. Okay, that is also okay. List of I. Okay, if somewhere key is equals to list of I, means if, for example, if any element you have taken that is equals to the element which is present in the list, if it is equals, then assign the new position or record the new position, that is position is equals to the whichever found the new location, that is I. Make it I. Yes, this is the step. Next, the last step is if position variable is not equals to -1, means if position is equals to -1 means non-existing position, means search is not successful simply. So if position is not equals to -1 means obviously we have the element in the list. That is why here position is not equals to -1, that print position. Print position means if position is not equals to -1 means element is present in the list. So note down that position. That's why I have written print position. This is the simple algorithm for sequential search or linear search. Say, now we'll take one example and we'll trace it how this actually linear or sequential search will works. So let me take some elements right over here. Okay, I would like to take 5 elements randomly, 1, 2, 3, 4 and 5. Okay, say this is first element 15, 19, 46, 52 and 9. These are the elements of the array. Then see, the first step is read list. Okay, now we read the list means these are the elements are stored in array. Correct. First step is over. Then go for second step, that is read key element. We have to take the key element, also called as search element. So now I will take element or key as anyway. For example, I would like to take key is equals to 46. Okay. Now already we said position equals to -1. You can write here also, but let me consider position is initialized to -1 now. Okay. So what are the indexes for this? This is a 0th index, first, second, third and fourth index. These are the indexes. Obviously we know that 0 to 4 the size is what? 5. So directly I will write n is equals to 5. From 0 to 4 total numbers are 5 numbers, that is the size of the array. Okay, fine. Now what is the next step right here? Loop I equals to 0, I is initialized to 0, the variable I is initialized to 0. Then I is less than n. I means what again? I write here I is less than n. Okay. Then what is this I? I is initialized here only, that is 0 is less than n means what? N means 5. 5. Yes. Is 0 is less than 5? Yes. True. Then enter the loop. In that loop we have the condition like if key is equals to list. What is key now? Key is a search element. I have taken key as 46. So take if 46 is equals to I write here list of I. Okay. Again same step I repeat here. 46 is equals to list of I. List of I means what? I is equals to 0. So list of 0. List of 0 means what? This is the list. List of 0 means what? 15. Yes, check it. Is 46 is equals to 15? No, false. 46 is not equals to 15, then this condition is fails. So increment I by 1, that is I plus plus, increment it I equals to 1. So here also I becomes 1 and I is less than n means what? 1 is less than 5, again it is true. Come here. What is key is equals to list of I? Key means what? Key means again 46, it is still the same, equals to list of I. What is list of I? I was before 0, now I become 1. So list of not 0, list of 1. What is list of 1? List of 1 is nothing but 19. So I can write here list of 1 is 9. Is 46 is equals to 19. Again false. So leave it, increment I by 1. Now I becomes, here I will write I becomes 2. Right? Then I is less than n. So I means what? 2. I write here 2 is less than 5 because n is 5. Okay. Now check if, again come here, key is equals to list of 5. Key means what? I written 46 only right here is equals to list of I. List of I means in the ith value we have 2. So list of 2. Correct? Okay. What is present in list of 2? List of 0, list of 1, list of 2. List of 2 means what? This is the element. Correct? That is 46. Now you check, is 46 is equals to 46? Yes, that is true. It means if it is true, then come out of the loop. So here only, if it is true, we have to record a new position, that is position is equals to, here it is, position is equals to I. I means what? I is 2. Okay. Okay. We recorded the new position, that is 2. See now, position is equals to 2. Go here, position is equals to 2. Yes, obviously in the second position or position number 2, we have the element as 46, which is same as key element. Correct. It means that now element is found in the list. Then go for the last step, that is check the condition. If I write here, okay, if what is there, position is not equals to -1. Yes, position means what right now? 2. Correct. 2 is not equals to -1. Position means new position which is recorded, right? Position is equals to 2. So which is 2 is not equals to -1. Yes, 2 is not equals to -1. True. 2 is never equals to -1. True. And print that position. Here printing the position in the sense the element is present in that position. That is why we are going to print the position. While we are writing the code, we can write the element is found at the location and you print that element and also that position. Okay. And also we can write search is successful if the element is present found in that position, or if there is no element which is given as a key element, then search is unsuccessful. So here print position. This is how we are going to search with help of this algorithm for sequential or linear search. So fine. How this search is done now? See, we started with the 0. Yes, from I to 0, 0. We compared with the key element which I have taken, that 46. Okay, right now 46. This 46 is compared with the first element, that is 15, but this is not the same element as the key element. So we incremented to the next cell, that is first position. Again we compared 19 with the 46. No, then we incremented, and for the third means second position, we compared 46 with 46. There we got the element and we recorded the position and printed. This is how search in a linear search means. Searching takes place by comparing with the key elements one after the other. That is why this is linear or sequential search. I hope this is clear to you. Okay. Now let me take one more example to trace this sequential search. Okay. Say the search element is 10. Okay. Now I have taken the search element as 10, and obviously again size is n is equals to 5 only. 0 to 4 means 5. Okay. See now, again we have to start from here. First step is over. Read the list. read key element is right, position is -1, we set the position and enter the loop, because we have to start from the beginning and go like this, that is I equals to 0. Now I will write here directly I is equals to 0. Now I would write directly all the steps, like I is less than n, directly I write I means what, 0, 0 is less than n means what, 5, true, right. Then enter the loop. What is the condition right here? Key is equals to list of I, directly write key means what, 10, 10 is equals to list of I, right here, see, list of I. What is list of I? List of I means 0, start from 0, list of 0, list of 0 means 15, right, 15. Check, is 10 equals to 15? False. Increment it by 1, I becomes 1. Now you will check, is 1 is less than 5? True. Okay. Then check if key is equals to list of I, again key is 10, list of I means list of 0. Now it is 1, so list of 1, go for here, that is list of 1 is nothing but 19. Again this is false. Okay. Then increment again by 1, that is I becomes 2, here also I becomes 2, 2 is less than 5, again true. Okay. Then again search element is 10, is equals to list of I means 2, list of 2 means right here. Now we are checking right here. Okay. Okay. 2 means this element. What is the element is 46. We checked here, failed, checked, failed, now we are here, correct. This is also false, again incremented by 1, that is I becomes 3, then 3 is less than 5, again it is true. Okay. Again search element will be the same, 10, and list of I, list of 3 means we are searching right here. What is list of 3, right? 52. So I write 52. Is 10 equals to 52? Again fails. So increment it by 1, that is I becomes 4, and here also 4 is less than 5, again it is 2 only. 10 is equals to list of 4, list of 4 is nothing but 9, so write 9 here. Is 10 is equals to 9, again it is fails. Then what will happen? Again loop will be incremented by 1, means I will be incremented by 1, that is I write here I becomes 5. Okay. Okay. Now you will check the condition right here. Is 5 less than 5? Here only it fails. Condition will be false, because 5 is equals to 5, but 5 is not less than 5, right? If it is false, it will not enter the loop at all. So if condition will not work, it come out of the loop. So again, what is the last step right here? If we have position is not equals to -1, we are not recorded any new position because no element found. So obviously the position is still -1 only. So I write -1 is not equals to -1, false. Why this is false? Because -1 is equals to -1, correct? So this is false, so we cannot print the new position. It means search is unsuccessful. This is how the algorithm can be traced for linear and sequential search. Then what we found by tracing these two elements? At the first time we found the element at second position, means after 3 comparisons, right? Now there is no key element like 10 in the entire list, even though we compared each and every element with the key element. This is the worst case. And what is the best case? Best case is the one where, let us say, the element is key element is itself is 15. If the key element is 15, that will be there in the first time only. For the first comparison only, we will get the element, or we will stop there only. We are not going to compare these, correct? That is best case. And what is average case? Average case is the one, the total number of comparisons with the total size will get the average case. But the disadvantage of this linear search is, even though we don't have the element, or we have to make lot of comparisons. Correct. See, 10 was not there in the list at all, but we compared all the, means 1, 2, 3, 4, 5 times we compared. That is the disadvantage of this linear search. Okay. I hope this is clear to you. Now we will write a program to use the same algorithm, and we will write program to linear or sequential search. Fine. Now I can write the program. We already know the algorithm, so I start directly to write a program. And now I am writing program with the same algorithm, and also we can write the program with the help of functions, and also with the help of recursion we can use. So directly I write very simple program right here, that is, okay, we start with the main, right? Main. Okay, take the variables what are required here. I go for first step, that is read the array elements. So that we have to write, I write here printf. We can also read the size of the array and compare with that, take that size in that condition. So directly I will take the size, printf enter the array elements. Enter the array elements. Okay, I am writing directly enter the array elements. Where is array? I told that array should be declared before they are used in the program. So let me declare array, that is int. I will take array name as ARR. This is array. Okay, and we have to specify the size. Let me give 5 again. Okay, now n is equals to 5 only. Here only I will take maximum number can be stored as 5. We can also store only 3. Correct. Now enter the array elements. Now how to read the array elements? There are more number of elements are there, so that we have to take any loop. Now I will take for loop for I is equals to 0. This is for indexing, and it is not declared yet. I will declare later. I is equals to 0. I is less than, the condition is total size of the array. So we can also read by the keyboard size, but I will take directly size as n is equals to 5. Directly I have taken size, that is I is less than n and I is incremented by 1. Correct. Now what was the condition right here? In the loop only we are going to read all the elements, because one by one we have to read. Here you take scanf. What type of array it is? Array is of type integer, so better you write %d. Okay, and comma, to store in the address we have to take ampersand with the array name array. Where to store? In the index is from 0, starting from the 0, that is array of I. Very simple. Correct. Then close this loop. Now first step is over, read the elements or read the list. The second step is read the key element or search element. Now I will write printf enter the key element. Correct. We are going to take the element to search. Taking new line, enter the key element. I write here to read the key element scan f. Key element is again integer, because we have values of type integer only. %d you take, and ampersand of, I take the variable as key. You can also take ele, means element or search element or key element, whatever. Take this. Okay, key I have to declare. I declare here. Correct. Then the next step is reading key element is over, and I told that we have to set the position to non-existing position. I will set it. Position is equals to -1. This is non-existing position. non-existing position. Right? Then where is position? This is a variable, so I have to declare here position. Correct. Now now we need to check the each and every element with the key element with the help of looping statements. For start from the first element, that is 0, and I is less than n and I is incremented by 1. Here check the condition. If what is the element? I have taken key, right? We entered key, so I directly write key is equals to element from the array. What is array? ARR. How to check array? Starting from 0 means that is I, array of I, right? And here right. If key is equals to array element, what was the algorithm? Record the position and set it to the new position, that is I. Very simple. But while we are writing the code here, if the element found, for example, if we have only, correct, like this 10, 20, 30 and 40, let us say here I have taken only 4 elements. Our search element is 20. Okay, we need to compare first element with the 10. No, 10 we compared, but that is not key element, and shifted over here and compared with 20. Yes, here element found, means we are not going to check further elements. Here we have to stop it. Correct. Here only we got the element which we are searching, right? Then we don't have to search the next elements, right? That is why while writing the code, right here, after position is recorded or new position is stored, break here. We have to break it. If we break here, means it will come out of the loop. Not only this condition, it will come out of that entire loop, means we will get now. Close it and close the for loop. Now we will got the element. Okay. Now what was the last condition? If position is correct not equals to -1, then what it means? Print position we have written in the algorithm. So I will write here printf. I write in the shortcut pf means printf the element, okay, the element or key, the element found, okay, or you can take also the element %d found at location %d, correct. Then I can take here how to write that. First the element %d, this %d is for the element. What is the element, right? Element is the key element which we taken key, so I write here key, comma. Then this % is for position is recorded right here, so write POS, correct. Now this is how we are going to do. If position is not equals to 1, a search is successful. You can also write statement search is successful and element is found at the location of that particular location. And if position is not equals to -1, if it is false, then also you can write one more statement below. You write that printf the search is unsuccessful and the element is not found in the list. Likewise you can write I close the main method. This is how we are going to write program with the same algorithm. This is same program. If I trace again, the already what we traced with the help of algorithm, same tracing will take place instead of printing this. Okay, first it starts from here. Enter the array. Program will ask you to enter the array from the keyboard. You enter the array, how many elements you want, you enter, and later you enter the key element. You enter the key element, you will get the key element. Again make the comparison with the array elements with the key element. If found, note down. If no, then no element is found. This is how linear and or sequential search will works.